Assalamu alaikum wa rahmatullahi wa barakatuh. My dear students, I welcome you again with another video lecture on electricity. We are talking about, in the previous video we have talked about the factors on which resistance of a conductor depends. And we talk about that resistance of the conductor is directly proportional to length of the material. That is, R is directly proportional to length of the material. As the length of the material conductor increases, the resistance of the conductor will also increase. Okay, and we said that the resistance is inversely proportional to area of cross section of the conductor. As the area of cross section of the conductor increases, the resistance decreases. Okay. So this was first factor and this was second factor. The third factor was that the resistance of the conductor depends on the nature of the material. Okay, we derived an equation where we said R is equal to rho L divided by A, which is combination of these two equations. But here, in place of constant of proportionality, we have introduced a constant. Okay, that is called electrical resistivity. Okay, this constant is called electrical resistivity, or we call it as specific resistance, and this resistance depends on the nature of the material. Okay, so this will depend upon the nature of the material. What is material made up of? It is it iron? Is it copper? Is it silver? Is it gold, etc.? So it will depend on the nature of the material. What is material made up of? So this is rho. It's called electrical resistivity or specific resistance. And the fourth factor we talked about was temperature. And we said that in general case, as the temperature increases, the resistance increases. Okay, as the temperature increases, the resistance increases. It's general case, and it has been found that the resistance of all pure metals increases with rising temperature. However, the resistance of alloys like manganese, like constantan, like nichrome, okay, etc., are almost unaffected by temperature and practically does not increase with rise in temperature. So these were the four factors on which the resistance of the conductor depends. Let's now talk about the topic resistivity. What does this resistivity mean? So we have seen that R resistance is equal to rho L divided by A. Okay, this we have derived. This is a Greek letter which is rho, and I told you that this is electrical resistivity. It will depend upon the nature of the material. So this is called electrical resistivity, as I have told. Therefore, I can calculate electrical resistivity here, which implies that rho is equal to Ra divided by L. As you can see here, if I reduce the value of rho, it will come out to be Ra divided by L. Okay, this R is the resistance of the conductor, where R is resistance of the conductor. Okay, R is resistance. This is the resistance of the conductor, and this A is area of cross section. Okay, area of cross section, and this L is length of the conductor. Okay, So we shall obtain the definition of resistivity from this formula. For example, if there is a conductor of length L, okay, for example, I have a conductor here. It has length L. Suppose this is length L of this conductor, and it has a cross section of 1 meter square. Okay, let's assume that it has a cross section of 1 meter square, although it doesn't seem to be, but I will draw a conductor like this. Imagine that it has length L and area of cross section to be about, this is the area of cross section, okay, like this. This is 1 meter square. Let's assume to be its cross section as 1 meter square. Okay, such that the current enters and leaves the opposite end of the conductor. Then according to the formula, the resistivity would be, so the current enters here, for example, the current enters here and it will leave from this end. So as far as this this equation is concerned, so we will derive this equation as rho is equal to, here it's R, this is resistance R multiplied by area of cross section, here is 1, okay, here it is the area of cross section is 1. So I will draw this right here as 1, and length of the conductor is also 1 meter. So the length of the conductor is also 1. Okay, so I can deduce here that rho is equal to R. So rho is equal to R. What's rho? Rho is the electrical resistivity. This is resistivity. Okay, rho is resistivity and R is resistance. There is difference between resistivity and resistance. Resistance is the property of the conductor which resists the flow of electric current through it. Okay, this is resistance. This R is the property of the conductor which resists the flow of electric current through it. And from here, resistivity can be defined. This is resistance, and resistivity can be defined from here. Okay, so it can be defined. Resistivity of a conductor can be defined as the amount of resistance. I can write here as amount of resistance. So this is the amount of resistance. Remember that this rho is resistivity. So this is amount of resistance. Okay, amount of resistance offered by a conductor, offered by a conductor of length 1 meter, of length 1 meter, and area of cross section 1 meter square. Area of cross section 1 meter square, such that the current enters and leaves from its opposite faces. Okay, current enters and leaves from its opposite faces, such that the current enters and leaves from its opposite faces. Okay, so this is the definition of resistivity. So amount of resistance, resistivity is equal to the amount of resistance offered by a conductor of length 1 meter and area of cross section to be about 1 meter square, such that the current enters and leaves from its opposite face. Okay. So the SI unit of R is rho, as we have seen that SI unit of resistance. Okay, SI unit of resistance is rho, denoted by this letter. And we can calculate the SI unit of resistivity also. So from the definition, rho is equal to RA divided by L. So the SI unit of R is rho, and the SI unit of area is meter square, and the SI unit of length is meter. So 1 meter and 1 meter will cancel out. So the SI unit of resistivity is rho meter. And resistivity of a material varies with temperature. So increase in temperature results in an increase in resistivity in case of ohmic conductors. For example, we have material silver. Okay, we have material silver. Its resistivity is about 1.60 into 10⁻⁻8 ohm meter. Okay, this is the resistivity of silver, 1.60 into 10⁻⁸ ohm meter. And the resistivity of copper, if we talk about copper, it is about 1.62 into 10⁻⁸ ohm meter. Okay, and if we talk about aluminium, it is about 2.63 into 10⁻⁸ ohm meter. Okay, these are the conductors. Okay, these are conductors. If we talk about insulators, insulator like glass have resistivity of about 10⁻10 to 10⁻14 ohm meter. Okay, so this is the resistivity of conductor, which is very low as compared to the this resistivity of insulator. And if we talk about diamond has 10⁻12 to 10⁻13 ohm meter. And so on and so forth. The materials having a resistivity in the range of 10⁸8 ohm meter to 10⁻⁻8 ohm meter to 10⁻⁻6 ohm meter, they are considered to be very good conductors. Okay, they are very good conductors. They are very good conductors. And this resistivity, rubber and glass are very good insulators. Okay, and they have the resistivity in the order of 10⁻13 to 10⁻13 ohm meter to 10⁻17 ohm meter. So they are insulators. They are called insulators, and they are very good insulators. Okay, because they offer huge resistance as compared to these conductors.